The graphs of a quadratic functions are more complex than linear and exponential because they include a turning point that is either the location of a maximum or a minimum. So let's look at the first exercise here. Consider the simple quadratic function y equals negative x squared. So a is the leading coefficient, and then we're going to fill out the table below. For the first one, it's going to be if x is negative 3, then negative 2, then negative 1, then 0, 1, 2, 3. If you haven't noticed, you are given the x in each one of these, and you are solving to find y. So, since you have a negative on the outside, that means that no matter what, your answer is going to be negative. So it's going to be negative 3 squared. So it's going to be negative 9. Negative 2 squared is going to be negative 4. Negative 1 squared is going to be negative 1. 0 squared is 0. Negative 1 squared is negative 1. Negative 2 squared is negative 4. And negative 3 squared is negative 9. So you'll notice that we have the symmetry that we talked about in the last lesson. So now we're going to plot those points. The first one, when x is negative 3, y is negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. When x is negative 2, y is negative 4. When x is negative 1, y is negative 1. When x is 0, y is 0. And then we have a symmetry that we can create for those other points. So our range for this one is y is always going to be less than or equal to 0. Remember, the other way you could write this is negative infinity is as far down as it's going to go, and 0 is included. So that's as high as it will go. So we're going to use our graphing calculator with a standard window to sketch each of the following. What standard window means is that your x as far over as it will go is negative 10, as far to the right it will go is positive 10, and then positive 10, negative 10 for the y also, and which you see on the graphs there. So I'm going to input the Desmos graph of the first one, 3x squared plus 6x minus 4. So the things we need to pay attention to is that it crosses the y-axis at negative 4. It looks like it crosses before 1 and crosses a little before 3, and the turning point is at negative 1, negative 7. So we have a graph that looks something like this. For our next graph, you will see that the y-intercept is at positive 1, that it looks like the vertex, so where the turning point is at 3, 10, and it crosses again at 6, and crosses a little bit before 1. So the y-intercept is positive 1. In our last graph, you'll see that the y-intercept is at negative 4. The turning point is at negative 2, 4. Crosses the x-axis halfway between 1 and 0, and halfway between 4 and 5. So we have a parabola that looks like this. So we will explore the reason for this pattern more in the next exercise with much simpler quadratic functions. Use your calculator to sketch a graph of each of the following quadratics using the indicated window. So the indicated window, if you haven't noticed, is the standard window. So the first one that we're going to sketch is y equals 2x squared. So for y equals 2x squared, you will see that the y-intercept is at 0, 0. You have a point at 1, 2. You have another point at negative 1, 2. And it keeps going up from there. So our graph looks like this. Our next one, you will see is y equals 3x squared. Again, the y-intercept is at 0, 0. Our first point it goes through is 1, 3. Our next point it goes through is negative 1, 3. And it goes up from there. So it's a little bit skinnier of a graph than the first one. And finally, y equals 4x squared. You'll see that, again, my y-intercept is at 0, 0. And our first point it goes through is 1, 4. Our next point is 1, 4. So it's an even skinnier version of the graph. So our first one went through the point 1, 2 and the point negative 1, 2. Our second graph went through the point 1, 3 and through negative 1, 3. And our third graph went through the point negative 1, 4 and 1, 4. See if you can figure out a pattern there. So our first graph, y equals negative 2x squared. You will see that our y-intercept is 0, 0. Our first point it goes through is 1, negative 2. The second point is negative 1, negative 2. It goes through this way. So negative 1, negative 2, 1, negative 2. For this one, y-intercept is 0, 0. The first point goes through 1, negative 3, negative 1, negative 3, so it's an even skinnier graph. So 1, negative 3, negative 1, negative 3. And our last one, again, y-intercept is 0, 0, and it's going to go through 1, negative 4, and negative 1, negative 4. So you may have noticed that the first point that it goes through has to do with whatever is the A for the graph itself. So I'm going to move all of these off the screen and look at the first question. For quadratic, y equals ax squared plus bx plus c, fill in the blanks. The parabola will open upwards, in other words, look like the type of a quadratic function with a minimum value or a happy face if positive. The parabola will open downwards, in other words, look like the type of a quadratic function with a maximum value, or in other words, a sad face if the a is negative.